Today we have a characters list, and we asked to find how many subsequent palindromes of size of 3 exist. The palindrome is the sequence that reads identically from the end and from the start. So how can you think about this problem? And let's look at the characters. For every character, we have all possible subsequences that can start after it, like n of them. So it's A, B, C, A, B, A, and so on. So there are n factorial subsequences possible. But we have only length of 3. That means we can simplify solution if we think about this problem from a different angle. I already solved it, so I know the result, but let me show you how I thought about this to achieve the intuition that can solve it. So we have conditions: length is 3 and palindrome. And that means that palindrome of the length of the 3 is like this: A, B, C, and so on. And inside, in the middle of the 26 possible endings, there are 26 possible middles. From A to Z, it's 26. So the total count of all possible palindromes are 26 by 26. And our full string length is 10 to the power of 5. And that means if we just brute force all the possible palindromes to find it, we have brute force solution of 10 to the power of 7, and it's kind of too big. But if we just improve this metric, this would possibly be pass as a solution. So how can we think about this metric to check it? We already spot that we have these conditions. Let's observe how can they be placed in our string. So it can be like this: A, then some characters, then A, and everything in the middle, and then any other possible like characters. And for any characters in the middle, there is a plus to the result, and this too. However, they should be unique. So we can possibly have this like A, B, C, D, A, B, C, D. And that means this is 3 palindromes, because we have 3 characters between all the A's. This also like this, and so on. What if we have more than 2 same letters, like this: A, 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 and this will be, for example, B, C, B, C. So what does that mean? So we have this and this, and they should be unique, but we also can assume that every letter between the leftmost and the rightmost is a palindrome middle, because A is also the palindrome. So that gives us the final algorithm, that we should first find the leftmost letter and the rightmost letter, and then count how many unique characters we have between, and just repeat it for all the possible letters A to Z. Then find first and last, then count unique. For counting unique, you can use hash set. So it would be like this: set first to the last. And this is like sum for all of them. So this is entire solution, and in a language like Python, it can look exactly like this. And basically this is the algorithm. The time complexity is of 1, because we have only 26 letters, and this is a constant. The find operation and count operation, this is O of n, time complexity, and this is find and count in just a linear scan. So this is O of n. The space complexity can be achieved of 1, because we don't have to store any actual substrings letters, we can just use pointers. I solved this problem in 2023, first time. The solution was kind different, but it's still the same of scanning intermediate values. I didn't see any other ways to solve it. So all those other people solve it like this. We can use some optimizations like Boolean array to count how many uniques they have. But essentially it is the same algorithm. Yep, this is like bitmask. Yep, that's it. Now you can watch how I solved it in 11 or 12 minutes.